Okay. So today we're looking at compound interest. Compound interest. Compound interest is what banks do for different things, right? So first question, I think I asked you this on Monday, but okay, why do most people, you included maybe, choose to put money in a bank versus keeping it at home, somewhere safe, lock it up? Why do we choose banks instead? Yeah. Because the money grows while it's in the bank, right? If I were to put $100 in my big secure safe, come back in a year, open up the safe, it's still the same amount of money, right? It hasn't grown. In the bank, it has a chance to grow. It's called interest, right? The bank pays you interest for giving us money. The bank's like, we will thank you by giving you interest. Now, it depends on your bank how big the interest is. If you have a few $100s, probably pennies interest, but if you have thousands, it could be more. It grows over time. Okay. Um, here's my another question. Okay, so bank pays me interest. Let's say they pay me a couple dollars interest every year. Not that much. I have a couple $100s. They pay me a couple dollars interest every month, every year. That's not very much, but they have thousands of customers. That's a lot of money. How are they able? How does a bank make money? In other words, how does a bank make money so that not only can they pay me my interest and everyone else their interest, but they also make a lot of money? What is that called? Yeah, by using other people's money, which is called loans. Yeah, they give out loans. They give out loans. The biggest thing that the bank does is giving out loans. If I give the bank $100, I say, put this money in my bank account. Someone else comes in, does the same thing. Someone else comes in and says the same thing. A lot of people do the same thing. The bank's got a lot of money. So what they'll do is they'll take that money. Someone comes in and says, I want to buy a new car. It's $30,000. I don't have $30,000. I only have $5,000. So I need $25,000 to buy the car. Can I get a loan from you? The bank has you fill out an application. Application says, do you have a job? How much money do you make? How long have you been at that job? Right? Do you go to school? What do you do? What else is there? Can you pay? In other words, they're trying to figure out if you can pay back, right? If they feel that you're safe, they give you the loan. Say, here's 25,000, go buy the car. So you pay back the loan, right? Over time, cars are usually 3 to 5 years. You got time to pay, so you pay back money every month to the bank, right? When you come, so I borrow 25,000. I don't pay 25,000 to the bank. I pay more than 25,000. Depends on what the interest rate is. Right now, interest rates are super high, right? Or they're not super high, but they're higher than they've been for a while, right? So I'm going to pay back a little more. So you might pay back over the course of 3 or 5 years. You might give the bank back 30, 35,000 for a car that for things something you just borrowed for 25,000, right? So that money that they make, right? You paid them back 35,000. You borrowed 25,000. That extra 10,000, that's how they make money. And they do that. They give out loans 10 times a day, if that, probably more than that, right? So let's say this is what happened. It happened in 2008. It happened in 2008, so a while ago, but still, it happened. And it can happen. Banks give out too many bad loans, right? It happened in 2008. People were getting loans that they shouldn't have gotten. They couldn't pay back, but the banks were giving loans. Bank goes bankrupt. Bankrupt means I have no money. Whoa. I had $500 in your bank. Do I get money back? What happens? Do I lose the money? Here's the thing. You guys are mostly juniors, so you guys are learning about Great Depression, right? Black Tuesday. I think it was Black Tuesday. This is what happened on Black Tuesday. Every bank went out of business. There are pictures of lines around the corner of people trying to get in the bank to get their money, but the bank says, we don't have your money, right? So on Black Tuesday in 1929, you were out of luck. You lost your money. What happened was President Roosevelt, President FDR, said, yeah, that can't happen anymore. So what they did was they signed one of the new deals was something called the FDIC, the Federal Deposit Insurance Commission. It's insurance on your money. So if the bank gets robbed, if the bank goes out of business, you're insured. My $500 will be insured. The government will write you a check and say, here's your check, right? So your money is insured. You don't have to worry about the bank getting robbed, the bank going out of business, right? Any of that kind of stuff. So luckily, yeah, after that happened, you're okay. So every bank you walk into, you'll see a little plaque. It says FDIC. That means it's part of the insurance commission. Now, every bank has to be a part of that. You can't be a bank without being a part of the FDIC. So you're okay there. Okay? Okay, so let's see. Okay, so how does the bank determine how much money to put in my account? There's two ways. There's two formulas that they use. The first formula is the top one. That's if you know how many times it's going to be compounded. Compounded, what does compounded mean? It means how many times do they put money in your bank account? Interest, how many times do they drop money in your bank? They can do it daily. They can do it hourly. They can do it monthly. They can do it quarterly, 4 times a year. They can do it yearly. Just depends on your bank. How many times do you put money, interest in my bank account, right? So if we know how many times, we use the top one, right? If we don't know how many times, we use the bottom one. If they just say we compound it continuously. Well, can I put a number on continuously? If you say I continuously do something, can you put a number on it? Is it every minute, every second, every 10 seconds, every hour? What is continuously? So if we don't know how many times they put money in our account, we use the second formula. Okay, so what do all those letters mean? It's on the board too, but here's what they all mean. A is the total amount. How much money do you have in your bank account right now, or after 10 years, or after 15 years, whatever it is, right? P, capital P, is principal, not like Mr. Holterman, but a principal is how much you start with. If I want to start a business, I can't just say, okay, I want to start a business. You got to have money to buy things, right? If I want to start a bank account, I can't go to Bank of America, Citibank. I can't go there and say, can I open a bank account? Like, sure, what do you want to start with? You got to have some money to put in the account, okay? That's what's called principal, okay? R is the interest rate. How much money are they what percent? It's usually in a percent, so we got to change that to a decimal. Just like we did the last 2 days, if you want to change it, divide it by 100. Divide it by 100, okay? N is the number of times they get compounded in 1 year. How often are you putting money in my bank account? I think my bank, at least once a month. I don't know how many times exactly, but it's at least once a month because they email me a statement saying this is how much money you have right now. And it's always interest on there. So at least once a month. I'm not quite sure how often they do it, okay? If it's continuously, notice how continuously formula doesn't have an N because we don't know how many times continuously is. That's why we have that formula. T is the number of years, right? The more years you have money in your bank account, the bigger it's going to get. If you just put money in an account for 1 year, like I said, you'll make a couple bucks in interest. If you put it in for years, at the end of 10 years, you're going to have a lot more money. So E, continuously formula has something called E. E is a special number, kind of like pi. Pi is a special number. Has nothing to do with pi, but it's called Euler's number. It looks like Euler's number, but it's German. In German, you don't say Euler's, you say Euler's. Okay? It's Euler's number. It's around 2.71828. It's like pi. It keeps going forever and ever and ever. It's a button on your calculator. I will show you where that button is. Every calculator, every scientific calculator has that button. Okay? Desmos has that button. Delta Math has that button. Those calculators in the back have that button. Okay? We use that continuously because, again, we don't know how many times. How often do they put money in your account? Continuously. I don't know what that means. I don't know how much that is, okay? Okay. So, first example. Tanya is investing $390 into an account, right? So it's either, there's a couple different things you can do in a bank. You can just have a regular savings account, checking account, or you can have what's called a mutual fund, some sort of fund that you're going to put money in and not take money out, right? Like I have a retirement fund. My retirement fund, every month I dump money in there. I can't touch it until I retire, until I hit a certain age. Once I retire, here's the money, right? And they give me about 10% interest, 10% interest, right? So I put money in every month. When I retire, they say, here's your money, all right? So it gains about 10% interest in there. That's a different account. That if you just have a regular checking account, savings account, you can pull money in, take money out as much as you want, okay? But some, like I said, some, your parents might, I have this for my kids, I have education accounts, or I put money in every month for my kids' education when they go to college. I can't take any money out until they go to college. Otherwise you get hit with taxes and everything like that. But when they're ready to go to college, I take that money and I have it for college, something like that too. Long-term, short-term, they have different things. So this one, I don't know if it's a long-term or short-term, but it's $390 into an account. It's paying interest of 2.7 and it's compounded daily. Okay. So first thing we got to do is we got to figure out, so after 18 years, if Tanya doesn't put any more money in, how much money is going to be there at the end of 18 years? That's what we're trying to figure out. Okay. So we're going to use not continuously formula because it tells me daily. Daily, you can put a number on. In 1 year, how many times is daily? 365, right? 365 days in most. This year, it's 366 because we have leap year, but most years, 365. Okay, so we're going to use this formula here. Okay. All right, so let's list what we have. We don't know A. A is the guy I want to find out. A is the total amount after 18 years. Principal, I know how much she started with, right? It's $390. What's the next one? R, I know it's 2.7, but again, that's percent. So I'm going to have to divide by 100. Divide that by 100, I get 0.027. N, number of times compounded in 1 year. If it's daily, in 1 year, it's going to be 365. So every day, once a day, they're putting money into her account. Time after 18 years. So now I'm going to put it into my equation. 0.027 over 365. And then I have 365 times 18. From here, I go to my calculator. The first thing I'm going to do, I learned this last period. The calculator does not like to multiply powers. It doesn't allow you to multiply powers. Okay? Or I know how to do it. Okay, so it didn't last period, but I think I got a workaround. Okay? So let's go to our calculators. Let's go to, like I said, Desmos, Delta Math, those calculators in the back. Any scientific calculator can do that. Oops. There we go. Okay. So we got 390. Oops. Parentheses. 1 plus fraction. Our fraction was 0.027. 365, right? Parentheses. Now I need a power. Well, the power, I'm going to use parentheses too. Make sure you use parentheses for the power because this is the only way to do it. I had 365 times 18, right? Close parentheses. There we go. So when you do a power and you're multiplying a power especially, use parentheses. Otherwise, if you just try to do 365 times 18, it won't let you do it. So use parentheses. Okay? So $634 and change. It says round to the nearest cent. The nearest cent is the same as the hundredths place. So $635.05 right now. So is it going to go up to 5 or stay at, or up to 6 or stay at 5? Stay at 5, right? Because that guy right there, 0, says stay. So it's going to stay at 5 cents. So $634.05. $634.05. That's how much she would have after 18 years. Now, she gained over $200, $240. It's not a lot of money after 18 years, but again, she didn't start out with very much. If you want to get money to go up, you got to do what the next person did. Austin. So Austin's got more money to spend, more money to invest, I should say. Okay? Because of that, they give him a better percent. That's how banks work. The more money you give them, the better rates they'll give you. Okay? This one's compounded quarterly. How many times is quarterly in 1 year? 4 times, right? 4 quarters makes $1, so 4 times. After 11 years, okay? So since we know it's 4 times, continuous, not continuously, we're going to use this one again. We're going to use the same formula we used on the last problem. Okay, A is the amount of money after 11 years. Don't know that right now. P is the principal. How much did he start with? 60,000. R is the rate. Okay, again, that's a percent. I need to change that by dividing by 100. .047. N, number of times. If it's quarterly, it's 4 times in 1 year. And then he's only going to keep it for 11 years. Okay. 60,000. 1 plus 0.047 over 4 to the 4 times 11 power. Calculator. $60,000. Don't use commas. The calculator doesn't like commas. Even though it has a comma right there, it doesn't like commas. So don't use commas. Just use, when you write it down, you can use commas, but not in the calculator. 1 plus, oops, forgot the 1, R, 0.047 over 4. Close the parentheses, to the, parentheses again, 4 times 11. Over $100,000. Okay, so let's see how much they want us to round to. They want us to round to the nearest $100. The nearest $100. Hundreds is in this position here. So the 3 is in the hundreds. So we have 2 options. Stay at 300 or go up to 400. Since it's 316, we're going to stay at 300. So it's going to be 100,000, 3 zeros all the way across. Everything else crosses out to be zeros after the 3. So $100,300. So he got over $40,000 for doing nothing, for just having his money in a bank account. Right? A little better. Like I said, the more money you put in, the more interest. Okay. Okay. So Hannah's got $820. She invests, she gets an interest rate of 1.8. This one's compounded continuously. I can't put a number on continuously, so that's where I'm going to use this guy here. I'm going to use the second formula that I have not used yet. Okay. Assuming no deposits after 16 years, how much? Okay, so I need A is what I don't know. P, how much did she start with? $820. E is in your calculator. You don't have to worry about E. I'll show you where that is. R is 1.8%. Well, you have to divide it by 100. That makes 0.018 and 16 years. Okay. Plug it in. Calculator time. So like I said, every calculator has the E button. You just got to find it. Okay, so $820. So $820 E. On Desmos or on Delta Math, you just go to the you just literally put in the letter E. You literally type in the letter E. On a regular calculator, it's there. Okay, on a regular calculator, it's there. Okay, so now we need power, parentheses. So I need to multiply 0.018 times 16. There you go. So that one's $1,093.68, it looks like about. So let's see how they want us to round. We always round the way they want us to, the nearest $100 again. They want us to round to the nearest $100 again. Well, $100, the 3 is in the ones, 9 is in the tens, 0 is in the hundreds. So I have two options, stay at 0 or go up to 1. Go up to 1 because the 9 in the 10 spot says go up. So it's going to be 1,100 zeros across. 1,100 zeros across. Okay. Okay, so the last two, we're only going to do 2 more. I'm not going to give you any extra problems. The last 2, they're going to change it up. Right now, we've solved for A every time. Now, they're going to have us solve for P, or they might have us solve for R. Okay, so that's the difference between the last 2 and what we just did. Okay. So Grace is going to invest in an account paying an interest of 3.8% compounded continuously. Continuously means this formula here. How much would Grace need to invest for the value to reach $46,000? So she wants the total amount to be $46,000. So this is $46,000. How much does she start out with? We don't know. That's what we're trying to find, right? Her rate, again, divide by 100. You're going to get 0.038. 13 years she wants to keep her money in. This is kind of like my retirement account. I know what number I want to reach when I retire. So I need to figure out how much money do I need to put in. You kind of figure that out, right? That's what I do. Okay, it's kind of that's how it's set up. So that's the math I needed to do when I was set up the account. Okay, so we know A is $46,000. I don't know what P is. I know they're going to give me a rate of 3.8%, and I know she's going to keep it in for 13 years. Now I have to solve for P. So I got to solve. Here's my question. So I have 4 options. I can add, subtract, multiply, and divide. Which one am I going to do? This is how I know. P is the guy I want to stay, right? Everything else. Let me circle everything else. Everything else here. That stuff I don't want to be there. I want P to be by itself. I want P to be equals, right? So I have 4 options. Add, subtract, multiply, divide, that other stuff. How do I know which one I'm going to do? Well, what is P doing with that stuff? Is it being added with that stuff? Is it being subtracted with that stuff? Multiplied with that stuff? Or is it being divided by that stuff? It's multiplying, right? P is multiplying. Anytime a letter and a number are stuck together, or letters are stuck together, that's multiplication. What's the opposite of multiplication? So that's what I'm going to do. I'm going to divide by the stuff that I don't want. And luckily, my calculator is going to help me out with that. Anything divided by itself just makes a 1 here. So that becomes 1p on this side. So my calculator, I'm going to put this. Okay. So I'm going to go back to my calculator, and I'm going to put a division problem. 46,000 divided by E. E, go to ABCs, put E. Power, parentheses, 0.038 times, how many years? 13. $28,068.32, I think. We gotta round however they want us to. So I'm going to go back and I'm going to see how do they want us to round. They wanted us to round to the nearest cent, the nearest penny. Well, cents are the 100th spot. So cents is the 1. So I have 2 options. Go stay at 1 or go up to 2. Go up to 2, right? The 6 behind it, the 6 to the right says go up. So it's going to be 32 cents. 32 cents. $28,068.32. Okay. That's how much Grace would need to invest at the start if she wanted to make $46,000 in 13 years based on that percent interest. Okay, that's how to solve for P. Last thing we're going to do is solve for R now. The last one is solve for the rate. What rate do you need? That's how you decide which bank you want to go to. What rate are you going to give me? What rate are you going to give me? The people who give you the best rate are the ones who get your business. Okay. So Oscar is going to have, he's got a big chunk of money. He wants to invest $79,000. That's how much he's going to put in. He's going to leave it there for 9 years. Assuming the interest is compounded monthly, we're going to use this formula here because we know how many times monthly is in 1 year. What percent does he need to get $96,000 at the end of 9 years? That's the number he needs to hit. Okay. A is the total amount. How much does he need? $96,000, right? He's ready to invest $79,000. That's how much money he's willing to put in right now. We don't know R. R is our question mark right now. Compounded monthly. So if I do something monthly, how many times have I done it in 1 year? 12. And then time, he's going to keep it in for 9 years. So let's go fill in my equation. $96,000, $79,000. 1 plus, don't know what R is, so I'm going to leave R alone. And then 12 times 9 power. Okay, so 9, I'm going to do the power first. 9 times 12 is 108. So it's 108 power, 108 power. Okay, so I got to solve for R. So I need my blue line. I need to solve for R. This is kind of like what we did. We did this. We solved for R on Monday and yesterday. There was problems where you needed to solve for the rate. It was the growth rate or decay rate. It's the same thing. The only difference here is that there's no such thing as decay rate when I put money in the bank. It's not going to go down. Unless you're investing in a company, if I'm putting money in a bank, it's not going to go down. It's only going to go up unless I take money out. Okay? Okay, so how do I solve for R? Well, the first thing is distribute, right? Can I distribute? No, same reason I couldn't last time. That power there. If that power was not there, I could easily distribute, but I can't. So when I couldn't distribute the last time, what did I do? Divided. Did the opposite, divided. So I'm going to go to my calculator and I'm going to divide this guy. $96,000 divided by $79,000, and you're going to get a decimal, 1 point something. $1.2152. So let's go 1.2152. 4 spaces past the decimal. I like to go to the 10,000 spot. Okay, 1.2152. Okay, what's left over here is this stuff over here. 1 plus R divided by 12 to the 108 power. I need to get into what's in here, right? So what did I do yesterday and Monday? It's the root, right? So this one's a 108 power. So the opposite is 108 root. When we match it, it goes away. So now what I got to do in my calculator is find the 108 root for 1.2152. Luckily, my calculator memorizes it. That number there. So what I'm going to say is I'm going to tell my calculator, okay, what I want you to do is take the 108 root for that number previous answer. I'm going to give you a number 1.018. 0018. 1.0018. No more root. No more power, no more root. How do I solve for r now? What's the next step? Subtract 1 from both sides. Good. Minus 1 whole from both sides. So I'm going to go back to my calculator and say, remember that long 1.0018 number? Subtract 1 from that. Previous answer, minus 1. 0.0018. Okay. Almost got r by itself. One more step to get r by itself. Not add by 12, you're close. Multiply, right? That's division, opposite multiplication. Yep. Multiply both sides by 12. So I'm going to go to my calculator and I'm going to say, remember that long number again that I have going? Multiply it by 12. Previous answer times 12. 0.0217. Let's say 0.0217. Most of the time, when they tell us interest rate, it's given as a percent. How do I change that to a percent? So that's when I want to do the opposite. That's when I want to change it to a decimal. What if I want to go the other way? Multiply by 100, yeah. Multiply that number times 100. And you're going to get 2.17%. The question says they want you to round to the nearest tenth of a percent. So the 1 is in the 10th spot, so it's going to be 2.2%. Done. That's the percent needed. That's the interest needed so that he can make the money that he needs to make to get that, to get whatever goal he had. Okay? All right. Okay, so tape that in 37, and tomorrow we'll do some practice, and then Friday we'll start reviewing.